Hi, I'm Vesna Stojanoska. I'm an associate professor at the University of Illinois in Urbana-Champaign.
Hi, I'm Kathryn Hess. I'm a professor at the EPFL in Lausanne, Switzerland.
Hi, my name is Magdalena Kedziorek. I'm an associate professor at the University in Nijmegen in the Netherlands.
Hi, I'm Sarah Whitehouse. I'm a professor at the University of Sheffield here in the UK.
Our program is entitled Equivariant Homotopy Theory in Context. And to give you an idea, equivariant homotopy theory is a part of mathematics that studies geometric shapes, geometric objects, equipped with additional symmetries. So the idea is to use the structure given by those symmetries to develop more powerful invariants to study those geometric shapes, topological spaces, and more generally spectra.
So in the last couple of decades, equivariant homotopy theory has been developed in a way that makes it a powerful tool not only to answer questions that encode symmetries in their formulation, but also as a tool to study non-equivariant questions. And a very prominent example of this was the solution to the Carré invariant 1 problem. Since then, the methods of equivariant homotopy theory have really been developed to whole new levels. And right now we're at the moment where we can reap the benefits of the development of those tools and solve new problems that come from different areas of mathematics, including algebra and geometry and others.
So among the main challenges of equivariant homotopy theory in general are the fact that there are often several different possible approaches to integrating equivariance into more classical areas of homotopy theory. And one thing we need to understand is the relationship between these different approaches, to play them off against each other to see what we can exploit in this way, and to understand just how much more information we can get by taking into account this equivariant structure. Because it's not just a matter of straightforwardly introducing equivariance, but to figure out how to do it in a way that enables us to exploit as much structure as possible from these questions. And also to understand how the interplay with other new developments in homotopy theory, including motivic homotopy theory, chromatic homotopy theory, and the interplay among the three.
Maybe I could just add something to that. I think one of the challenges of the subject is making it accessible to new people coming in, because already homotopy theory has a bit of a reputation as being a subject with quite high startup costs, a lot to learn before you can do new research. And then when you add equivariance into the mix as well, then that's adding more challenges. So one of the things that we've been trying to do throughout the program and with our workshops is to involve as many junior people as possible, early career researchers, PhD students and postdocs, and to create opportunities for them to begin to become really members of the community and to help them find accessible routes into the subject area.
I would say it's a little bit early to talk about breakthroughs just yet. We are halfway through the program, a little bit after halfway through the program. But yes, there has been significant progress with many different directions or areas that people have been working on for years. One such example is the understanding of rational algebraic models, so rational G spectra for G being any compact Lie group. I think currently we're very close to having a complete understanding for any compact Lie group of that area.
Area of recent accomplishments, and some of them were done here during our program, were the development of tools for studying algebras in this equivariant setting, and so in particular the equivariant notions of the trace methods that are used to study algebraic K-theory.
Another important point has to do with developing a better understanding of transfer systems, which underlie a lot of what a global approach to understanding genuine equivariant spectra. And in this context, it's really interesting because there's a very close tie with combinatorics as well. So there's a very interesting interplay with combinatorics. And so through the connection with combinatorics, there's a better understanding of what's going on in the equivariant stable homotopy theory side, but also new insights in combinatorics. And one nice thing about this area is that there's a relatively low entrance fee, so that even undergraduates can get involved in projects that have to do with these transfer systems.
So maybe I'll say something more general. Speaking to, as Magdalena mentioned, it's a bit early. I mean, we have talked about some of the outputs already that we can identify from the programme, but I think more generally, what you hope for a programme like this, you hope that it's really helping to lay the foundations for the subject for the next several years. And we really hope that we're doing that. I mean, I already spoke about our involvement of early career researchers, and we're seeing lots of people, including lots of junior people, sort of very actively working in new groups or maybe in already established collaborations in the building. And I think we're also trying to contribute a little bit to the nature of the community and making it a welcoming community. We had an EDI event which was a little bit different to ones I've been involved in before. We had a panel discussion about building and maintaining a welcoming community in the subject area. And I think all of this is to say that, yeah, it is a bit early, but we really hope we're contributing both in terms of research and more generally to laying the foundations for maybe the next decade of this subject area.
So our field has applications, I would say, Equivariant homotopy theory has applications to classical homotopy theory, providing new insights and enabling computations in that way. It has applications within mathematics beyond homotopy theory, to algebraic geometry, to number theory, and so on, to mathematical physics, gauge theories and such. But also, and this is really special about topology as well, there are many applications beyond topology, including in equivariant context. For example, equivariance is starting to be more and more important in the world of machine learning. So, I think there's great potential for even further applications of some of the mathematics being done this semester, maybe not immediately, but in the relatively near future in some of these areas. So because of the strong connections that there are between topology and applied areas beyond mathematics, we are going to have an Open for Business today at the end of the program, in which we'll explore applications of topology in the life sciences, where topological methods have proved to be particularly powerful and revealing.
Yeah, I mean, I think I would like to come back to some of the things about community building and involvement of early career researchers. So we haven't really talked in detail about the workshops, but one of the ones we had already took place in April in Belfast. So it was a satellite workshop, and this one, I would say even more than the rest of the programme and the other workshops, heavily involved junior people, and it included slots for contributed talks, so a lot of junior people had an opportunity to present their work. And so I think, I definitely want to emphasise that the future of the subject is the junior people and the bringing in new junior people all the time. So we have tried to emphasise this in several ways. Another activity that I could mention in this regard would be that we have a weekly gong show. So this means opportunities for participants to present, just 10 minutes, so really short talks. But this has been, well, lots of people have given these. It's a way of enabling a very large proportion of a programme's participants to at least present their work a little bit. And it serves to start conversations. So it's much easier for someone who don't know to talk to them about their mathematics if you've had this 10-minute introduction to the kinds of things that they're thinking about. So I think in several ways we're really trying to involve the junior people and thinking about how the future of the subject is going to evolve with new people coming in and hopefully us welcoming them into a community that they can be part of and contribute to. So for up till now, almost the entire time, we've had a parallel programme in the modern history of mathematics, and we had some nice interactions between our programme and that programme. In particular, there was a joint Zeeman 100 event, which was to celebrate 100 years after the birth of Christopher Zeeman, and we had a talk and video and then discussion, and this involved lots of participants from both programs. And that's just an example. I mean, maybe it's the most prominent one, but we had lots of nice interactions. And, well, so there's just been recently a changeover of programs, so we haven't really had the opportunity yet to establish too much interaction with the current program in uncertainty prediction that's now running parallel to us for the rest of our program. But I think I'm just trying to speak a bit to the fact that these activities, the INI and these programs, they also help to build the coherence and community across mathematics much more broadly than just within the program topics.
So I've been in Cambridge a few times before this, and I really enjoy being at the Newton Institute. For one, I find the architecture of this building to be a great sort of inspirational place. It makes things happen, not only for sitting down and doing your work, but also for interacting with the other participants. One of the things I enjoy about my time here and about us organizing this program is the opportunity for all of us here as participants to generate new ideas and perhaps free from the pressure of sort of measuring progress towards a specific goal. So I think we are trying to create this space that is an open ground where we are not trying to solve a particular problem, but we are trying to generate ideas. And in particular, for my own research, that's what I am focused on.
So for me, it's the third semester program which I've participated at the INI, and it's always a great pleasure to spend time here, a real privilege actually. So for me, it's a particularly special visit to the INI, because for the last 4 years I had a more leadership and management position, had very little time for research. So being here has provided me with an opportunity to actually discover research again, to rediscover the joys and occasional frustrations of doing research, and to realize that, yes, this is it's a tremendous privilege to be in a place that is so conducive to doing research, so inspiring for research, to be part of a community of researchers. And for me, it's been a marvelous way to jumpstart my research career again. So I'm delighted to have been able to spend time here.
This is my second time participating in a semester program at the Newton Institute. The first one was in 2018. That was the HHH program. I was just a postdoc then, but somehow I got invited for the whole 6 months, and I think that has been an amazing opportunity for the development of my career and my research. And as such, I was absolutely sure that I want to organize a program just to pay it back to the next generations of mathematicians. And I was very excited that all three of you joined me in this. I particularly like Cambridge. There's something about the Newton Institute, as Vesna just mentioned. The building is just so open that just being here invites new collaborations.
So I've been a participant at several things over the years here, but this is the first time that I've been an organiser of a programme. I'm really enjoying it. I mean, I've always enjoyed my time here. I echo all the comments that my fellow organisers have made about the nature of this place and how conducive it is to doing mathematics. This time around, I have a new collaborator, someone who was invited for a couple of weeks earlier on in the programme, and we're already quite well advanced in writing a paper. So, it's been extremely productive, in ways that one can pin down, as well as in all those more ways that might take, months or years to play out before they result in new published mathematics. Maybe another thing to say is that it's been really a pleasure to watch my PhD students when they've been here, and again, it sort of echoes the things I said more generally about the early career people. But I've had students come and seen them asking questions, making contact, both with, you know, the world-leading researchers who we have here, and then also with their fellow PhD students or, you know, other early career people, and you can see that they're building those networks, and, you know, but at least potentially that's going to lead on to collaborations and joint papers. So that's a really nice aspect, is sort of seeing the junior people, how it is for those people for whom it's a new thing to experience this